Hello everyone, this is Amal with AP. This is the fourth video of the series of videos where we are discussing descriptive statistics. The topic for today is range and quartile. Let's learn. As a quick recap, descriptive statistics deals with two important phenomena, central tendency and dispersion. Central tendency deals with the location of data, where majority of the data is located is being depicted by central tendency. The dispersion, on the other hand, deals with the spread or the breadth of data, how dispersed the data is, how much variance is there in the data, right? So mean, median, and mode, which we have already discussed in previous videos, are the markers or the matrices for the central tendency. But for dispersion, we have variance, standard deviation, range, quartiles, skewness, kurtosis, and various other mechanisms or matrices. The topic for today is range and quartiles. We'll be discussing that. Let's move on. First question, what is range? Range is very simple. As the name sounds, it talks about the breadth of the data in a data series. So suppose you have a bunch of numbers. What is the breadth? What is the minimum value and the maximum value? How far and wide the data is spread is the range. So range of a series can be defined as maximum value minus minimum value. This is our running example which we have been covering in this particular series of videos. So on the left column you can see the number of students or the student roll numbers. On the right is the placement package in the lakhs per annum. So as you can see, one student, the roll number 10, got lucky and he got a 80 lakh package per annum with the US placements, which is roughly around 100k US dollars. Okay, the rest of the students got between 3 and 9 lakhs per annum. Okay, so what will be the range of this? The maximum value is 80. The minimum value or the minimum lakhs per annum package which a student got was 3. So the range of this particular data series or the placement package will be 80 minus 3, 77. That's what range is. Very simple. What are quartiles? Now the word quartiles came from quarter or 1/4, right? So it essentially means the same thing. If you are doing, if you are bucketing your data of a data series into quarters, that's what the quartiles represent. So as you can see on the picture over here, if we have bunch of data and what we are trying to do is to bucket them into the first 25% of the data and then second 25%, then we'll reach the halfway mark, which will be median or the 50th percentile. Then again 25% of the data, which will take us to the 3/4 or the third quartile, 75% mark. And then we'll have the rest of the 25 data. Now friends, the important thing to note over here is that these data should be arranged in an ascending order. Then only it will make sense. So as you have noticed that in previous videos that when we are calculating median, we had the data in the ordered form, in an ascending format. So similarly for calculating the quartiles also we have to arrange. Let's see how it is calculated with our example. So how it's calculated. Now this was the example which we have shown just a few minutes back. Now I have ordered this data series. Okay, so we have the 15 observations or the 15 students for whom we have the placement package in lakhs per annum. I have sorted them in ascending order. Now the question is how to find the first quartile, median. Median we already know, it's the halfway mark, the third quartile, and things like that. Okay, let's see. So the first quartile, let's talk about the median first. The median is the mid value. So there are 15 observations. My observation number 8 will be the midpoint. There will be 7 numbers before that and 7 numbers after that. So it's very simple. It's very intuitive also that what is the median. In an ordered series, the halfway mark is median. Now, median we have already figured out. What will be the first quartile? The first quartile with the median of the first half of the median, if it makes sense, right? So how many data are above the median? Now there are 7 data points above the median. What will be the midpoint of that? The midpoint of that will be the 4th number of the series, right? So incidentally that LPA is also 4 over here. That will be my 25 percentile or the first quartile. Similarly, if we have to find the third quartile, then we have to see from the data over here from the median. How many data points are there? 7, because my median was the 8th data point. Now we have 7 data points. What will be the mid of that? The mid of that will be my 12th data points. 3 on the below, 3 on the above, right? Make sense? So this will be my third quartile or the 75th percentile. Now this works out very well if the number of data is odd. Okay, so the question would be that what if we have an even number of data sets, right? What will happen then? The answer is simple. Let's say you have an even number of data. Instead of 7 on the top, you have 8 numbers. What you will do? You'll take the median of the middle two numbers. That's it. Like how you were doing in the median case, in the quartile case also, you will take the median of the, or the mean of the middle two numbers. Let's say there was a 3 and 4 which comes. So 3.5 will become the mean, which will be my 25th percentile or the first quartile of the number. Okay, in case the number is even. Okay, so that's how we calculate the first quartile, median, and the third quartile. Okay, let's move on. There is something called interquartile range also, IQR. Now, what is this IQR thing? IQR is very simple. It's just a fancy word, but the essence is very simple. So if you have figured out the third quartile and the first quartile, you have to subtract third quartile minus first quartile, and that will give you the IQR or the interquartile range. So what is the distance between the third quartile and the first quartile is the interquartile range, right? So in case of our example, my number 7 or 7 LPA is the third quartile, 4 is the first quartile. The number 7 minus 4 will be 3. 3 is my IQR. Now let me ask you two questions. The first question is, does a first quartile number needs to be present in that number or the data series? Let me repeat that. So if I have to find a first quartile, does that number have to be in the data series or not? The answer is no. Why? In case the as I was saying, that if the number is even, then you have to take a mean of the middle two numbers, right? So 3 and 4, let's say, the 3.5 will be the mean. If 3.5 is the mean, that number is not present in the data series, but that can be act as a first quartile. That's fine. The first quartile doesn't need to be. It's just a marker on a number line that this is where 25% of the data lies on the left or before that, and 75% of the data lies on the right side or after that. That's all it says. So 3.5 is a perfectly valid first quartile. Okay. Now the second question is, we understood quartile, which is 1/4, or we are bucketing into quarters. What is percentile? In many of the competitive exams, you may have seen that here this person got 99.5 percentile marks. Now, what is this 99.5 percentile or 99 percentile? 99 percentile means that you are dividing this not in 4 quarters, but in 100 different buckets. Okay, so 99 percentile means that 99% of the people is before he or she. Okay, so 99% of the people got less than what that person got as a marks, if it's a competitive exam, let's say, and only 1% of the people or the students who appeared for the exam got more than that particular. So that's what 99 percentile means. Okay, I hope, friends, that is clear. So what is a box and whisker plot? Box and whisker plot is nothing but a graphical way of representing the spread of the data. So what we have been doing with our ranges or IQR or quartiles is the same way, but represented graphically, and it's also used in outlier detection. Let's quickly see that how it works. So the first thing which, friends, you'll notice is that this is the same data set, right? And this is arranged in an ascending order. Now this is what it's called the box and whisker plot. The midpoint or the central rectangle which you are seeing is the box, and the perpendicular lines to that, these are the points which are called whiskers. Okay, the down one over here and there. So that's why it is called box and whisker plot. Now how it is plotted? The plotted is simple. If you see the middle rectangle and there is a line in between, okay, the line which is passing through that rectangle, that is my median. The top line, this particular line of the edge of the rectangle, is my third quartile, and the bottom of the edge of the rectangle is my first quartile. So my first quartile median, and the third quartile are represented by these rectangular boxes. Now, what are those whiskers or those perpendicular lines? Those represents the minimum and the maximum data points. Okay. And friend, if you notice over here, there is a singular data point over here which is at 80. And if you have guessed it, then full points to you. This is what an outlier looks like. And the box plot is mainly used for outlier detection, right? And figuring out in a graphical way how the data is spread out. We are going to discuss more about outlier detection in the next video. But just to summarize what a box and whisker plot is, 4 data points. You have the maximum value, the minimum value, you have the outlier, you have the third quartile, median, and the first quartile. And with this, you can get an idea of how spread the data is. Okay. Now, the question was I think I have already given the answer, but what's the use of the IQR and the box plot? So one thing is for sure that they show the spread and the dispersion of the data. That's fine. But they are also used in outlier detection, which we are going to discuss in the next video. So with that being said, I think I will wrap this video at this point, and I will see you all in the next video. Thank you.